Hey everyone, so we just finished talking about solving quadratics. So we're going to take it one step further and talk a little bit more about solving quadratics more in the graphical sense. We only really talked about it in the algebraic sense. For those who don't know, algebraic is just a fancy way of saying mathematically. And when we mean graphically, we're going to be plotting the equation onto a graph in order to find the same solutions. So remember that when we used math in the last unit, we could have found the solutions of a quadratic by either factoring, using the quadratic formula, or completing the square. Remember, completing the square had the much longer process, but did get you straight to the answer, while quadratic kind of required a little bit more finesse and um, simplifying. The quadratic formula, for those who may have forgotten, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then the factoring method, which if you remember, couldn't always be done. It was something that we kind of had to do in special cases. Typically, quadratic formula and completing the square was used for any quadratic, but factoring was only in special cases because not every quadratic equation can be factored. The equations that we're going to talk about here can be factored, so that's how we're going to be able to plot them on a graph for the most part. Um, like I said, these solutions can also be found using a graph. Now, if you recall, I briefly mentioned that when we graph a quadratic, the solutions that we're talking about are actually representing the points where the graph crosses, this is a typo, crosses the x-axis. So wherever the graph crosses the x-axis, that horizontal line, the one that goes left and right, that is going to be the solutions that we've talked about. Now, some other terms that you might hear for these solutions are sometimes called the roots or the zeros of the graph. Because again, it's the points where when we plug in a value for x, we get a zero value. So again, if you have a graph that looks like this, so this will be your y-axis, this horizontal line will be your x-axis. You can have a solution that looks like this, and these points where it crosses the x-axis, those are your solutions that we've been talking about, or the roots, or the zeros. All right, so I want you to sketch three possible solutions for quadratic equations. So there's going to be one for zero solutions, one for one solution, and one for two solutions. So draw it out, pause video, work itself, and we'll go over in a second. All right, so a zero solution graph would look something like this. Now, of course, you could have it anywhere up here, anywhere down here, but the idea is that it doesn't even come close to the x-axis. Again, the solutions are where it crosses the x. So when we say zero solutions, it means it never crosses the x-axis. If it starts above the x-axis, every point is above the x-axis. If it starts below, every point's below. For one solution, that means that it can only touch the x-axis once. Well, the only point where it's only equal to that value one time is right here at the bottom. So we'd have to make it so that it just touches it just a bit, just for one single point. That would be an example of one solution. Again, it could be curved upwards anywhere along this x-axis, or even curved downwards, something like this. This is another example. I'll draw another one for zero solutions. Two solutions is the most common. Again, it's got to cross the x-axis twice. So it could go like this or like this. Any of these is an example of two solutions because it crosses once and twice. Once and twice. All right. Now, typically when you're trying to graph a quadratic and you're trying to find the solutions from that, there's a few different ways. First, since most of you should have graphing calculators, you can actually plug it in and see from there. But for the most part, if you're being asked to show your work on how you graph it, what you'd want to do is first factor the equation, and find the solutions to that quadratic. Again, these are going to be the points that cross the x-axis. So then you put those points on your graph. Then what you want to do is pick a few points in between those two solutions. So if you had numbers like if you found that your solutions were 0 and 1, then you might want to pick some numbers in between 0 and 1, like 0.5. And you plug them into the quadratic to see what you get for a value. Again, when you plug in a 0 or a 1 into the quadratic equation, you're supposed to end up getting 0. That's how you know that you got those right. You do the same thing, but plug in a different number and see what you get, and that becomes one of your other graphing points. Typically, you only want to really do like maybe 3 or so, just so that you can figure out, how high up it goes. But for the most part, it's going to be fairly symmetric. And then when graphing a quadratic, you would then also want to connect the points like a parabola. And then you would double check by using a graphing calculator and plugging in the quadratic equation. I should actually go back. When I said pick points in between, you definitely want to make sure that you pick the middle point in between the numbers. Again, if your solutions were 0 and 1, you'd want to pick a point halfway in between, which was 0.5 or 1 half. If your solutions were 0 and 2, you'd pick 1 as your point, because again, that's going to be where the parabola makes its little turn, and you want to know exactly how high that point is. All right, so that's pretty much it. We'll do a few practice questions where you're going to solve a quadratic algebraically and then verify it by graphing it either on a graphing calculator or by plugging the numbers in. All right, so pause video, work itself, and we'll go over in a second. All right, so what we're going to do here is we're going to try to simplify this a bit. We have to move the 6 over just like we always do. Now we're going to analyze the quadratic, which is going to be 3x squared minus 5x minus 6 equals 0. I'm not really going to be able to factor this, so I'm just going to use the quadratic formula. So a is 3, b is negative 5, and c is negative 6. Quadratic is negative b plus or minus the square root of b squared, negative 5 squared minus 4ac all over 2a. So we end up getting, this becomes a 5. When I plug everything in underneath this radical, I end up getting a 97. And then down here I get a 6. 97 is not a perfect square, and I can't really do anything with it. So my solutions will be 5 over 6 minus radical 97 over 6 and 5 over 6 plus radical 97 over 6. So from here, I can actually already answer questions C and D. The number of solutions that I get is 2 solutions, but both of these are what we call irrational numbers. Remember, irrational numbers are numbers that aren't whole numbers and aren't fractions. While there are fractions in here, the fact that there's a square root tells it's irrational. Now, if I want to graph this and actually check the solutions, what you would do is plug into your graphing calculator 3x squared minus 5x minus 6 into the y line, and then you'll see that if, let's say this is negative 1, and 1, 2, 3, the graph ends up going something like this. It will end up passing through, just missing the negative 1, going all the way down, and then coming up past the 2. I can check this, making sure that it passes relatively around here by actually plugging these numbers into the calculator. So if you do 5 minus radical 97 and then divide that by 6. This is negative 0.808, which is slightly less than negative 1. And then this one, when I do 5 plus radical 97 and then divide that by 6, I end up getting about 2.47, which is halfway between 2 and 3. Like I said, normally when you are being asked for solutions, you do want to keep it in the fraction form, in this simplified form. You do not want to give it in decimal, but if you're going to graph it and check, you need to make sure that you check based off of the decimal. All right. Here's the next question. Pause the video where itself, and we'll go over in a second. Now, this one is a lot nicer. You might be confused about the y, but it doesn't change anything. We're going to do the same thing where we move everything but the y term over to the other side. So add the 12x over, and we get y equals negative 4x squared plus 12x minus 8. To find the solutions, we basically just turn this y into 0. And then we could do what we normally do. Since all these numbers can be divided by negative 4, I'll divide it by negative 4. Do the whole greatest common factor. So this ends up becoming an x squared. This becomes minus 3x. And this ends up becoming a plus 2. So my equation is now going to be x squared minus 3x plus 2 to get the solutions. When I graph this, I can factor this very easily. Two numbers that multiply to 2 and add to negative 3 will be x minus 2 and x minus 1. Because negative 1 and negative 2 multiply to 2, add to negative 3, set each of these factors equal to 0, and we end up getting x equals 2 over here and x equals 1 over here. So my solution set will be 1, 2. Going to C and D, there are two solutions, and they are both rational. When I graph this on the graph paper, what I end up seeing is something that looks like this. So that's going to be 1, that's going to be 2. We see the graph coming up from the bottom, crossing 1, crossing 2, and peaking at about 1. So we can check all this out. If you wanted to, you can actually double check to make sure that if you plug in a 1.5 into this original equation, you should end up getting that y equals 1. And that's pretty much it. So my graph does verify my solutions. And here's the last one. Pause the video, work itself, and we'll go over in a second. All right, so once again, same thing as before. We're going to take this, move everything to one side. So I'm actually going to move the 3x squared over. And I end up with 3x squared plus 36x plus 108. What I can do from here is I can actually, like always, GCF it out. All these numbers are divisible by 3. So this becomes x squared. This becomes 36 divided by 3 is a 12. And 108 divided by 3 is 36. Now, one thing, if you can't tell just by looking at it, this actually is what we would call a perfect square. So 36 is a perfect square, x is a perfect square, and the numbers that multiply to get 36 will add up to 12. So my solutions will actually end up being x plus 6 and x plus 6. So looking at this, setting both these equal to 0, they're the same factors, so we can actually just ignore the other one and solve for one of them, and we get negative 6. So going down here, there's only one solution to this, negative 6, and it is a rational number. Again, it's a whole number. Now remember, when we only have one solution, it should just cross the x-axis one time. So when we graph it, we actually do find that if this is -6, it comes from the top down, crosses right there, and then comes back up. So your graph should end up looking something like this. And that's basically it. We're going to talk a little bit about solving quadratics a little bit more, as well as other things and how it relates to graphing and all that stuff. If you have any questions, please feel free to let me know, reach out to Remind, join the extra help. Otherwise, I'll see you later. Good luck and have a great day.